Hey everybody, thank you for joining me. We're going to look at linear functions in context today. That is the goal of our class. And so you can look at linear functions in graphs, equations, tables, and in words. So here is tonight's agenda. You're going to complete a do now. You're going to take a quick quiz. You'll want to stop the video and take the quiz, and then I would suggest you watch this video as you complete the 3 examples. Show your work in the Google Documents or on a separate piece of paper, take a screenshot, and then upload it. So the do now is right here. It asks you to write an equation in point slope form to model the situation, and then rewrite the equation in slope intercept form. So we're given the number of text messages in the independent variable column or the X column, and the total bill in the dependent variable or the Y column. And your bill depends on, the cost of the bill depends on the number of text messages. So I'm going to find the slope, the rate of change. And when I look at the number of text messages, I can see that's increasing by 5. And that is true all the way through this table. Plus 5, plus 5. Let me decrease this a bit. When I look at the total cost, that's going up by $1. And I can see that is happening for all of these values. So remember, slope is change in y over change in x. So my slope is $1 per 5 text messages, which equals 20 cents a text. So I have my slope. So to write this equation in point slope form, I can pick any point I want, sub it into point slope form. So I'm going to choose 5, 26 using my 20 cents per text. Okay, so point slope form is y minus the y you know equals the slope times x minus the x you know. So y minus the y I know is 26 equals, the slope was 20 cents, 0.2, paren, x minus the x I know, which is 5. So from here, the next thing I need to do is rewrite this equation in slope-intercept form. To do that, I first need to distribute the 2/10 inside, and then slope-intercept form means to isolate or get y all by itself. So write it as y equals mx plus b. So let's distribute our 2/10 inside. So that's 2/10 x minus 2 times 5 is 10, and then I'll move my decimal 1 point, so 1 place to the left. So it's $1. And I'll rewrite the left-hand side of the equation. Okay, so from here, to isolate y, I have to add 26 to both sides. So I can see that I have isolated y on the left-hand side. And on the right-hand side, I have 0.2 plus 25. Okay, so that is the equation written in slope-intercept form. So there is a little link right here for you to try the quick quiz, which is in a Google form. It's also right here. And here are the different forms. Remember, standard form is x plus by equals c, and your x and y are on one side, the constants on the other. Try to get your x variable to be positive. Once you're done taking the quick quiz, come on back and we'll start looking at some of the context problems. So really, algebra is used to help us model the world around us and make sense of it. And it provides us with the tools we need to look at the relationship between two variables and then to try to make some generalization in an equation so that we can predict the future and analyze situations to make good choices. So the next few activities will model linear models and their relationships in real life contexts. So this is a nice cheat sheet that gives you all the information that you're going to need to help you with the next three problems. So video. So this is the problem. There is a link right here to the worksheet, and then you can always go back to the reference sheet. So your sheet looks like this. And it says a biologist takes several measurements of the concentration of contaminants in a lake after a chemical spill. After 4 hours, she measures 450 milligrams of contaminant per milliliter. And then after 12 hours, the concentration has decreased to 80 milligrams per milliliter. So we need to clearly define the variables. And how do we know which one's the independent variable, which one's the dependent variable? Well, the x is the independent variable, and I know that it is the time in hours. And the amount of contaminant depends on what time we're talking about it. So that's how I know that the contaminant is the dependent variable. Oops, I wrote y and I meant x. So y is the contaminant, and that's in milligrams per milliliter. All right, so what information, we're going to write the given information as points, or we're going to make a table. So the ordered pairs, remember, x comes before y. We have two ordered pairs here. So our first one is the 4, 450. And the second one is the 12, 60. So we can use those two ordered pairs to help us write our equation in slope-intercept form. So you want to just write the given information as points or ordered pairs. So that's pretty easy to do. So we have 4, 450 and 12, 60. So I can see that as my time is increasing, the amount of contaminant is going down. So that's a negative association or relationship. So to model this, we want to find the slope. And then we want to write the equation in point slope form, and then probably finally slope intercept form, because we need to make a prediction. So the first thing I'm going to do is find the slope, and remember it's change in y over change in x. So I'm going to take the difference of my y variables over the difference of my x variables. So it doesn't really matter which point you start with. So this, I can subtract 450 minus 60, because that's my y. And then 4 minus 12. And you can use a calculator. Please feel free to go to Desmos and punch this in. So 450 minus 60 is 390. And 4 minus 12 is negative 8. And when I divide 390 by 8, I get 48.75. And it's negative. So this is decreasing about 48 and 75 hundredths milligrams per milliliter every hour. That's what that means. All right, so the next thing I want to do is just choose one of these points and sub it in for into point slope form. So I'm going to choose the first point. So y minus the y I know is 450 equals the slope with negative 48.75 paren x minus the x I know, which is 4. All right, so interpret the meaning of the slope in the context of this scenario. So what's happening? Every hour, the contaminant decreases by 48, and that's just an average, 48.75 milligrams per milliliter. Okay. Use your model to estimate the time at which there is no more contaminant. All right, so that's when x, we're solving for x when y is 0. So the easiest thing to do is to go back to our equation and in point slope form and write it in slope intercept form. All right. So I'm going to take my y minus 450 equals, and I'm going to distribute or give out that negative 48.75. So I have negative 48, negative 48.75x and then we want to multiply a negative 48.7 times 5 times a positive, but times a negative 4, which makes it positive because 2 negatives make a positive, and that is 195. Okay, so from here, I'm going to just add 450 to both sides. I get y equals negative 48.75 plus, I'm going to add 450 to the 195, and then it equals 645. I'm sort of running out of room here. So now from here, I want to, oh, I forgot my x. Sorry about that. So from here, I'm just going to erase this and rewrite it so it's a little clearer for you. Okay, so the equation in slope-intercept form will help us because now we want to find out x when y is 0, when there's no contaminant left. So I'm going to take and set y equal to 0, and now I'm going to solve for x. Okay, so this means I need to subtract 645 from both sides and divide both sides of the equation by negative 48.75. So let's go ahead and do that. All right, so let me subtract 645 on the left side and the right side. So now I get negative 645 equals, these are opposites, so they cancel, and I'm only left with the negative 48.75 x, which is good. So then my next step is to undo my multiplication by dividing both sides by negative 48.75. And again, I would suggest that you use a Desmos calculator, and I will, at the end, I'll make sure that you are comfortable finding that link. So let's take 645 and divide it by 48.75, and we get about 13.23 hours, okay? So it's gonna take about a little bit less than 13 hours and 23 hundredths, or close to a quarter of an hour. So I'm going to actually clear all this now. And so the equation that I had used gave me about 13. So it will take about 13 hours and 15 minutes, or over 13 hours, or less than 14 hours, to remove all the contamination. And I'll make sure that that is in red for you, as is this. So interpret the meaning of the y-intercept. So the y-intercept is what the amount of contamination was when it first started. So if we go back to our equation, which I'm going to just write over here, our equation was y equals negative 48.75 x plus 645. So the y-intercept, because this is a slope-intercept form, is right there. So to interpret that, so there were the total contamination, or the total amount of the chemical spill, was 645 milligrams of contaminant per milliliter. And we want to write that. There were, for the initial spill, was 645 milligrams per milliliter. Okay, so that's example 2. Example 1. I think this was the hardest example. The next two are kind of easy, so easier, I should say. So this was using a lot. We had to find the slope given a point, write the equation in slope-intercept form, and we had to first use point-slope form to get there, and then we had to interpret the slope and the y-intercept, and we had to make a prediction using our model. So that was a pretty rigorous problem. Thank you for sticking with me. Let's go to the next problem. It says AMATYC, the American Mathematical Association of Two-Year Colleges, generated the table to model the percentages of community colleges offering distant learning in recent years. So we need to try to figure out if we can write a linear equation for this function. If so, we'll define our variables and write our model, and then interpret the slope. So remember, if this is a linear function, it's going to represent a constant rate of change. So let's take a look at our table and see if there's a constant rate of change. All right, so when I go from 1995 to 1997, that's 2 years, and that's an increase. When I go from 33 to 44, that's an increase of 11. So I'm going to take that. Remember, your slope is your change in y, and I'm using the symbol delta, which is a Greek letter for change, and change in x. Okay, so I'm going to do 11 over 2. So that's 11% increase per two. That's not very good. It's an ugly looking 11. My apologies. So if I divide 11 by 2, that's a 5.5. So it's about 5.5% per year. Now let's see if that is true for all of them. And what I mean is all the ordered pairs. So when we go from 97 to 98, that's an increase of 1 year. And if we take our calculator and we do 49.5 minus 44, we'll see that's an increase of 5.5%. So that one checks. All right. And let's take a look at going from 98 to 99. That's a 1 year increase. And if we use our calculator, take a second to type in 55 minus 49.5. And that's another 5.5% increase. So the last one we need to check, this is getting kind of ugly looking, sorry. The last one we need to check is going from 1999 to 2002. So that's that last pair. So if you count, from 1999 to 2002, that's 3 years. So that's a plus 3. And 71.5 minus 55 is 16.5. So now that we have our differences, we divide them. Change in y, which is my percent difference over the change in years, which is my x. And 16.5 divided by 3 equals 5.5. So yep, there is a constant rate of change. So can we model this? Yes. Why? Because there's a constant rate of change between the data, which represents a linear relationship. Yes, we can use a linear model because the data shows a constant rate of change. Oops. Okay. So to clearly define our variables, if we go back, the independent variable, the x variable, is the number of years. Is the years, and the y variable is the percent of community colleges offering distant learning in recent years. Now, I got this information looking at the table. So I looked right here. And I went back and I read the problem right there. So sometimes when I'm stuck, I have to go back and reread the problem or look at the graph or the table in this case. All right, so what's the next thing? Use an algebraic model for this table. All right, so we already got the slope, which is good. So the only other thing we need to do is it doesn't tell us how to write it, so let's use point slope form. So let's take one point. We can use that point, 33, 1995. That's a long time ago. Geez, my baby was born a year before that. So then we have our slope, and that was 5.5. And remember, point slope form is y minus the y you know equals the slope times x minus the x you know. So x1, y1 is the point that you know. So all we need to do is sub that information in. All right, so we have y minus, here's the y I know, 1995 equals, I've got the slope as 5.5 x, oh, got to put that in paren, minus the x I know is 33. Close that paren. Okay, so if I do it here in the table, I mean in the doc, y minus 1995 equals 5.5 paren x minus 33 close paren. All right. So the last thing is interpret the slope in the context of the problem. Well, in the context of the problem, what does this mean? Every year in the percent of community colleges offering distant learning is increasing by about 5.5%. So since 1995, the percentages of community, the percentage of community colleges offering distant learning increases by 5.5. Okay, so that is that problem. And you are doing a great job. I will I will suggest that perhaps you stop the video, take a little stretch break. We have one more to go. And these are actually going to get increasingly more easier. So the next one should be more comfortable than this one. So we're going on to the third example. It says corporations in the United States are doing quite well, thank you. The graph shows corporate profits in billions of dollars from 1998 to 2002. And so the years since 1990 is on the x-axis, profit is on the y-axis. It makes sense to me because your profit depends on the year you're talking about. So we need to interpret the 0.3520 in the context of this scenario. Okay, so 3 years. So after 3 years, corporation profits corporate profits are $520 billion. Find a linear model for the information shown in the graph. Clearly define the variables. All right, so we have to clearly define our variables. So let's do that first. So X is the year, number of years since 1990, and Y is the number of billion of dollars, is the profits. And that's in dollars. And it's in billions. of dollars. All right, so to write this equation, it doesn't tell us how to write it. Seeing how we're given a graph, and the graph is pretty easy to get the slope of and the y-intercept. Let's write it in slope-intercept form. So if we look at this, we can see from the graph, initially, it starts at 400. So that point right there, this is our y-intercept. What does that mean? 0, 400. Initially, in 1990, corporations were at $400 billion. And then we can use this point, and we can pick any points that we want that are easy to read, and we can go changing y over change x. Okay, so let me first make that point, and then here's another point that's easy to read. So we're going from 400 to 600, so that's 200, and we have to remember we're in billions of dollars, divided by, we're going from 0 to 5. That was 200. So the slope is about 40, and that's $1 billion per year. Per year. All right, so now we can model this situation because we have our y-intercept, which was 0, 400. So y minus the y we know, y equals mx plus b. So we have our m of 40 and we have our b of 400. So I'm going to go right here. And y equals 40x plus 400. And we really want to use lowercase letters in algebra. We use uppercase letters usually in geometry. Okay, clearly explain the meaning of the slope in the context of the problem. I think I verbally did that. So every year since 1990, corporations in U.S. see an increase of $40 billion in profits. You can word that however you want. You don't have to word it exactly like I did. Clearly explain the meaning of the vertical intercept in the context of the problem. All right, so in 1990, corporations, the profit was about $400 billion. In 1990, corporations' profits were $400 billion. And that's it. Great job. So make sure you take a snapshot of your work and include it in this. And I thank you for your effort. Really nice job. Once you submit this, let me know, and we'll touch bases with what else you need to do. If you have makeup work from the last couple of weeks, you definitely want to work on that. All right. Thanks, everybody. Appreciate you watching the video.